Everyone. I am Ashwin Shirsat, a third year electrical engineering PhD student at North Carolina State University. Today, I'll be presenting my research on data-driven demand response potential quantification. So what basically is demand response? It's the time periods during which the utility requires its customers to bring about a reduction in their consumption in order to maintain a healthy and secure demand-supply balance. Um, Residential demand is it's one of the largest share in the electricity market, and as such, it's been pretty underutilized. As you can see from the plot here, that of the total potential savings that could be achieved, about 50% or less had been realized in the last couple of years. This shows that there's a huge potential to tap into the residential demand response markets. And this figure shows the interaction of the demand response aggregator, which has basically been contracted by the utility to uh, manage and handle the demand response program. A demand response aggregator's key responsibility is to choose the right set of customers. But what happens here is that the customer behavior is highly uncertain, making the demand response aggregator's task very complicated. So some of the questions faced are like how the uncertain customer behavior can be modeled, how can the data be put to use, has the model need to be a specific one or a very generic one? So to answer these questions, we propose the use of a response learning model, which is highly data driven and can learn the inherent patterns in customer behavior. This histogram here shows how a typical response of customer generally looks like. The conventional approach, or the traditional approach, has been to fit a Gaussian distribution and then use the fitted distribution for the further analyses. But this distribution lacks taking into factor the values near the extremities. So for this, we need to use multimodal mixture distributions. And to learn these distributions, we'll be using a mixture density recurrent neural networks, or MDRNN. The figure here shows the typical layout of the entire model, MDRNN model, wherein the input is the hourly load, temperature, day of the week, hour of the day, with the training label of the historical reduction value. And the output, after passing through a cascaded LSTM or the RNN layer and the MDN layer, is the mixture weights, the mixture means, and the mixture standard deviations. Next question is like, how do we select the total number of mixtures that we want in the distribution? Total number. One could be on the basis of statistical analyses, like minimizing the training error, or we could do it using an empirical method. To briefly go over the algorithm used, it's shown here. We first put in our input data, which is of 3D format, and for every epoch, train the combined LSTM and the MDN. And to go quickly about the mathematics, the mixture means, mixture weights, and standard deviations are given by the formulas here. And the training error is a negative log likelihood, which we aim to minimize. The training and testing errors are shown here. The values closer to 0 are the best because we're using mean squared error. The RNN layer output is shown here, and we can see that it is not highly accurate, and that's why we need a probabilistic kind of predictions, for which the MDRNN results are shown in the figure here. We can see these complex distributions, mixture distributions that have been generated using the MDRNN help capture the spatiotemporal characteristics of the customer behavior. To validate our proposed approach, we perform a case study. For that, we first generate different scenarios for the stochastic analyses, and the scenarios using the MDRNN approach are highly diverse in nature, as can be seen from the figures here. And lastly, using these scenarios, we perform an optimal customer selection case study, wherein for using the MDRNN approach, we've been able to extract higher customer reduction by selecting the right set of customers. To conclude, we have been able to achieve multimodality in the mixtures. Scenario diversity has been captured, spatiotemporal elements in the customer behavior have been smoothly incorporated in, and a very intuitive way for stochastic analysis has been laid out. Thank you very much. If you'd like some additional information, please refer to my paper.